Hi, it's Mary with Insect Shield. I am here today with Dr. Brian Leydet. He's a professor at the SUNY College of Environmental Science and Forestry. Welcome, Brian.
Hi, Mary. Thanks for having me.
Absolutely. So first off, can you tell us about your background and what you're up to these days?
Yeah, so I started researching ticks about 15 years ago in the southern United States. My background's in public health, but I did my PhD at Louisiana State University School of Veterinary Medicine. Go Tigers! And did my work on ticks starting in Florida, then to Louisiana. Moved up to the Adirondacks here in upstate New York for my postdoc. Studied ticks up here and found a position here at SUNY College of Environmental Science and Forestry about 7-8 years ago, and I've been studying the behavior of ticks in the Northeast since then.
Okay, well, just to start, what got you interested in ticks in the first place?
That's a great story. So, initially, I was actually a paramedic. I was in emergency medicine for a long time, and I thought that was going to be my life track. But then I met a critical mentor in my life, Dr. Kerry Clark at the University of North Florida. I'll have to give him a shout out. And he took me under his wing because I was eager enough and volunteered in his lab and got me hooked on ticks. And from then on, I knew my path was to study ticks. I didn't want to study anything else. Now that has changed as I've branched out into other forms, but still mainly my focus and my love other than my family and friends are ticks.
So what are you studying now specifically about ticks, and what have you been focusing on?
Right. So my lab does a lot of different things. Right now, during COVID, we were a little under, but since COVID, we've really buckled up and we brought in a bunch of students, and we're doing projects understanding the spatial nature of ticks. Right. You can imagine, and people like to ask me, how many ticks are infected? And I'm in Syracuse, New York. How many ticks are infected in Syracuse, New York? And I'm like, well, that's a kind of a loaded trick question, because tick infection can vary from backyard to backyard to backyard. And that's one of the interesting natures of this disease, is that ticks don't move much in nature, right? They move up and down, the black-legged tick especially. And then horizontally, they have to take a ride. Right? They have a vehicle. They have the mice, the deer, those animals. Just like we get in our car and drive somewhere, ticks need to do the same thing. And so because of that, if we can understand how mice are moving in nature, how we drive cars, you can predict spatial distributions of the majority of ticks, and you can actually change that using certain cues or certain things. So we're investigating if we can predict or investigate or understand what determines where ticks are in the landscape, because ultimately the diseases that ticks spread are only a problem if ticks bite humans.
Right.
If we can eliminate the bite, either through protective measures or through eliminating the encounter, then you decrease. You decrease the likelihood of disease. We do it with mosquito-borne diseases like malaria, right? We give out bed nets, and if we sleep under a bed net, you protect yourself. That is protecting you from the actual bite of the mosquito. Now, it may sound a little harder with ticks, and it certainly is. But understanding the biology of what's influencing where they are is kind of what my lab is looking at, as well as things like novel detection methods. We collecting ticks is a very person power intensive feat. We have to go out with little white flags and drag them, miles to get ticks. And so I have some students investigating maybe more passive methods to detect ticks, especially in new areas. We do it a lot with other insects. When you think about invasive insects, there's always monitoring programs via passive monitoring, maybe insect traps set out and insects stick to the traps, so they fall in the traps and someone goes and monitor the traps, or more active processes where people are actually looking for the organisms. And we're trying to look at maybe some novel passive strategies to detect new tick populations.
So would that be like kind of a tick trap you would somehow make?
Kind of. There's a couple different options, and I'll keep. My student is very early in her master's degree on this, so I'll just kind of keep that research. Look for stuff coming forward on that stuff.
Gotcha.
On that research.
Now, this might be a little different off topic, but do we want to eradicate ticks, or where do ticks fall in the chain? Because I know that's the thing, like mosquitoes. I mean, people, I'll get rid of all of them, but there's that whole, every part of nature is there and is food for something else. Like, where do ticks fit into that? And do we need ticks?
I love this question because it's one of the questions I've been searching for my career, 15 years. Because mosquitoes are pollinators. They can actually pollinate flowers. They serve some benefit. They serve as food sources for certain insectivores. Ticks don't have so much of a role in nature versus being other than being a parasite. There are some probably evolutionary consequences to parasitism by ticks, but those are long-term processes that are still not well understood. If there weren't ticks, I probably wouldn't have a job. So that's kind of a benefit for ticks being out there. Now, as far as eradicating ticks, I would, with our current tools available, I would say that is not possible. So I don't think we need to focus on eradication of the tick. I think it's a great I think we should be chasing it as scientists. But at the larger scale, eradication's probably not the way to go. There's control, right? Knocking them down to a safe level, controlling exposure. And then ultimately, ticks are not everywhere yet, but they are certainly on the march. So what we do with other invasives is what we call slow the spread. So we don't just let ticks come in and establish, because once they're established, it's all downhill. The problem is that we're not putting much effort on slowing the spread. So we need to put more of an effort on understanding where they are, where they aren't, and how we may slow them from getting to new areas. And again, I don't have the answers for those, but some of the stuff we're interested in my lab at understanding.
Interesting. So were you, in your world, I mean, you all are out there, you want to collect ticks, you want to study ticks. I mean, when you're studying them, are you mostly looking at the germs because that's the whole thing with ticks, is the germs.
Sure.
And passing the germs on to people.
Right. I mean, that's the bread and butter of research, right? How does it affect humans? Because if they just bit and they didn't transmit anything, people would probably not be as concerned. But we do look at the germs. Lyme disease, Borrelia burgdorferi, is one of the more common ones. We look at things like Babesia and Anaplasma. But ultimately, it comes back to the behavior of the organism itself, because without that behavior and that contact to humans, it would not be a problem. Those germs would just hang out in nature and we would not care. There are a lot of different species of ticks, right? There are some ticks that a normal person would never encounter in their life, despite them being in their backyard, right? Because they're strictly associated with hosts, whether they're in burrows or in, tree holes or in nests. It's just something you're not going to come into contact with. And even though they may carry disease, the likelihood they spread that to you is very, very low. So if we could think about other ticks that are more generalist feeding behaviors and understanding why they contact humans at the rate they do, and can we change that is kind of what we're really interested in. And I really like the behavior. So, we have a current project right now, and people may think it's crazy, is I have a student going out, we collect the ticks, and every couple meters, the student stops and they take the ticks off the little white flag and they throw them back. Because we don't want to deplete the ticks, because we're doing repetitive sampling in an environment, and we don't want to take ticks away. It's called replacement sampling. It's a scientific way. Once we get something, we send it back, and then we could collect that tick again later, because that's, taking ticks out in nature at large rates is not natural. So we do things like that to try to understand how they're moving and where they are in the environment. And I think it's pretty fascinating. It's a lot of work for the student, but I think we're going to come up with some really cool findings.
Nice. No, and correct me if I'm wrong. So ticks, though, but like Lyme disease can affect humans, dogs, and is it horses?
Well, so it's a lot of different animals. Okay. Horses can have some effects. Cats can have an effect, and I like to separate. And it's good for the audience. I like to separate disease from like the presence of the bug, the parasite, the Borrelia, because disease is a manifestation of a negative effect on a host.
Okay.
Right? You can have a bad bug inside of you and not have quote unquote disease, right? For example, a lot of humans harbor B hemolytic strep, which is the organism that causes strep throat, and they harbor it naturally in their throat. It's only a problem when your microbiome is imbalanced and that strep becomes more prominent and causes the strep throat. So that's a very basic example. But some dogs, and I like to do this because I went to a vet school and I was surrounded by vets. And one thing the vets would tell me is that humans are wimps, right? So a dog could potentially have an infection with Burley burgdorferi that causes Lyme disease. If they don't have signs or symptoms, is it really disease, right? Does it really warrant treatment? Does a vet even know?
Right.
Right? So you have to balance that. Now in humans, if you get bit by the tick and the bacteria gets into you, you're probably going to develop a disease, which is a sign or symptom, and you will get treated for that. But in other organisms, it's really variable how they react and whether it's truly quote unquote disease or just an infection that may go away naturally.
Right. And if you don't have symptoms or you don't feel bad and you're not, then doesn't matter. Even like you could test that someone had the flu virus in them, but if you're not sick.
Right. So what I mean, like,
first.
do you take a Tylenol in the morning because you just think you may get a headache during the day, or like, or you're like, well, how does it hurt? Take a Tylenol. No, you don't take drugs unless you have signs or symptoms, against, that your body's reacting to it.
Right. Well, I think, obviously now it's more in the news with asymptomatic, like with COVID, how many, people, I never got COVID. And then they're like, but everyone in my family did. Well, I never, I felt fine. So did they, like, if you're not feeling bad, then it doesn't matter if you had COVID or not had COVID, for example.
It does on the side of transmission, right? You're still infectious. Okay. So it has that other caveat that we don't see tick-borne diseases. But as far as like feeling bad and disease, were you actually diseased? I teach a class about disease prevention, and we always talk about what exactly is health. And that is in the eye of the beholder, right? It's not an absence of disease, because you could wake up one day. I have some little flu running, or not flu, but sickness running through my family. I take some Dayquil. I'm at work. Am I healthy? Well, I'm healthy enough to work. Am I sick? I have a little cough. So, we have to balance that. Some days I'm too sick to get out of bed, right? So it's more of a continuum.
Well, yeah. And then I guess jumping onto like Lyme disease, that's really the big topic of Lyme disease, because many people get, I don't know the percentage, but the people that get bit, maybe they get the bullseye or not, or they feel sick, they immediately get treated, boom, they're fine. And then there's this other percentage of folks that are not diagnosed or don't have that relationship, and then it's 5 years later and they're finally diagnosed and they realize why they've been sick for 5 years.
And it's not a small percent, right? The estimates are 10 to 20% that some people are changed for their life, the rest of their life. Yeah. Some people are changed for an indiscriminate period of time, 6 months, 1 year, 5 years, 10 years, 15 years. And it's definitely true. It's happening. It's because of the past infection with the bacteria. What is happening in the human body? Again, it gets down to that individual level, like dogs and cats and horses, right? Some get sick, some don't. And we all have to realize that our bodies are all different. And when we're scientists or when we're talking about public health, we're talking about general, right? And there's all the extremes. There's people on this end that may just have a little sniffle. People on this end that are admitted to the hospital for the same infection. But then there's the people in the middle, which are the majority of the population. And when we're trying to make a difference from treatment, from prevention, who do we target? The extremes, or do we target the 95% of people that are in the middle of that hump? And we often target those people, realizing, there are extremes, but we're trying to do the most good, the biggest impact with the least resources. And the first time is to go after the larger proportion, and then work your way to everybody.
That makes sense. And I've spoken to people with, long-term Lyme that they believe they were bit many years ago, and then they had like a traumatic health event, and then like Lyme actually became a issue for their bodies.
Yeah. And again, this is not my expertise. I do follow the literature, and I'm in the middle of this whole thing. But it's the human body and the response to stress or the immune system's response to things is very individual. And a stressful or an event can cause a lot of downstream changes in the body or reactions that may or may not be due to prior infection, current infection, future infection. It's just to know that somebody is sick or not feeling good and to try to figure out how to make them better, whether it's through traditional medicine, integrative medicine, whether it's just through living a healthier lifestyle, right? The goal is to make the goal, and I'm not a physician, but I would imagine the goal for a physician was to make people feel better.
Right.
That's kind of where I stand on it. Again, we stay out of the human stuff, and I'm really on that tick. I'm like that guy's my interest.
Right.
To benefit humans, no doubt.
Right. Well, okay. So back to the tick itself. So what, so you're out there, you're studying them, learning their behavior. And so the ultimate goal would be just understanding them better. So people and other, and dogs and other mammals will get less sick by being less bitten. Is that the
less bitten? Yeah, and I've recently been giving some talks, and I came up with this. I don't know that we've spoken about this, but this Lyme disease equation or tick-borne disease equation, right? Thinking about it as a mathematical, like an operation, meaning you have the tick, you add the host, the reservoir host, right? They can differ, right? There's a whole span of them. You add the bacteria, the Borrelia burgdorferi, you add the human, and that all equals the disease. So when you're trying to change the disease, you take out all parts of the equation, right? Whether it's the tick, which is hard. I mean, you can take the tick out. Whether it's the host, whether it's the bacteria, through vaccination or other way. When we do it through host, we try to cull deer, we try to control mouse populations, or whether it's taking the human out of the equation through things like prevention, right? These are the kind of things where when you think about it, okay, it makes sense. When you put it up in visual terms, it really goes, okay, we're going to attack this, this, and this, or maybe all of the above in certain ways to decrease that equality that equals disease, right? To reduce that disease outcome. And so, I don't think it's going to be a silver bullet. It's got to be integrated. It's got to be an integrated approach. But there's certainly there's certainly novel things that we can exploit in these systems that my lab is investigating.
So when you're having talks and speaking to people about, tick prevention and what they can do, what's your list?
So, I mean, we've heard it a million times, but it doesn't make it any less relevant to this conversation. And I'm happy to say, we hear tuck your pants into your socks, right? Why? Well, because the ticks grab onto your lower extremities. So they could crawl under your pants to your head or on top of your pants to your head. Where are you more likely to see them, right? That goes into those light colored clothing, right? So you can see that little black tick crawling up your leg and you can swat them off. So it's not just saying, and I like to say, it's not just saying to do something, but why we do it. Explain the biology or the mechanism behind it, right? Things like wearing acaricides on your skin, on your clothes, whatever they may be designed for, repellents for your skin, actual acaricides that kill the ticks on your clothing. That's another step of prevention, this integrated approach. After you're in an area where there could be ticks, which is any grassy area. I mean, even my front yard can have ticks for a certain period of time. Doing a tick check when you get inside, right? What is that tick check? Well, it's these areas where ticks like to attach. We know they attach everywhere, but we know there's areas like the groin, under the armpits, behind the ears, moist areas that you don't see on your back. I do the freckle check. I know all my freckles. And if I see a new one, I go, that's probably not a freckle, right? Nor my kids' freckles, right? When, it's amazing. I have two young ones. I have a 6-year-old and a 2-year-old. And, a lot of kids aren't born with freckles. They develop freckles over time. So my 6-year-old is starting to develop new freckles. And every time I see one, I'm like, is that a tick? And I'm like, no, it's not a tick. It's a freckle. But it's like an alert on my head, to see this. So doing that tick check, if you have access to a dryer, taking your clothes that you've been out in, throwing them in the dryer to dry out any tick that hasn't been attached. If you don't have access to a dryer, which some people don't, hanging them outside in the heat, right? For an extended period of time can help ticks detach or die. And then obviously, if you do get a tick, detaching that tick with a simple technique of taking tweezers and just pulling them all and saving that tick. I hear too many times, not just from the public, but from even my colleagues at school, from my family members that have found a tick on me. What'd you do with it? I flushed it down the toilet. I'm like, that doesn't help the doctor if you're sick, right? If you get sick in a week, I'd rather you show up, and I'm not a physician, but I'd show up with a tick in a plastic bag and go, hey, doc, I got bit by this, and now I'm feeling this way. That helps that doctor diagnose. It gives them that evidence to help the doctor and you talk about what may be making you sick. So take that tick, put it in a bag, throw it in your freezer to kill it, put in some ethanol or some rubbing alcohol, put it in a container, save it until you're out of until you're free. A couple weeks, you're not feeling that bad. Okay, well, maybe it's time to get rid of that tick. Or I know there's a lot of services you can get tick testing services that are available across this country that can help you measure that likelihood of disease transmission, that quote unquote risk that you're willing to take based on your exposure, the tick, how long it's been on, kind of thing. And I want to add that the idea of the tick check after going outside is this biology of the transmission of these bacteria, these protozoa, and these viruses, is that the majority of them take a certain period of time before transmission occurs. Now, it's not a 36 hours, 24 hours, right? It goes back to that bell curve at normal distribution. The majority of transmission happens in this big hump. There's extremes. Again, it's science is not black and white. It is gray as anything. It's all shades of gray. 50 shades of gray, if I want to on there. But you have to realize that the longer the tick is attached, the more likely disease transmission has occurred. So the quicker you get it off, the less likely disease transmission has occurred. Not yes or no, it's more or less. So get it off as quick as possible. That's why we do the tick check.
Yeah, no, I think the saving of the tick, having a picture of the tick, and just having the baggie, putting in the freezer if needed, is huge. And I think if more people knew that step, just keep it. It would also could alleviate. It could give you knowledge, and like we talked before, I mean, at the end, knowledge it does have a germ, it doesn't have a germ. They can determine generally how long the tick was attached, which can be very important. But what type of tick? I think there's such a, we talk about the myths of ticks. One is that every tick has Lyme disease or carries. All types of ticks carry Lyme disease germ.
And that's certainly not true. There are species that don't. And we, in the lab, we've tried. My colleagues, scientists have tried to give them the disease, and they just don't take it. Or again, I'm not talking in black and white. I'm talking in gray. The 99.999% of them will never acquire the bacteria and never be able to transmit it. So there are some species where you're at higher risk for certain exposures than others, certainly.
Now, what? Oh wait, I just lost my train of thought there. What was I going to say? Okay, well, I'll go back to. So I guess because we love having different experts, kind of just different tips. Because I think the more people, for some people, one expert's that tip resonates. For another, so even if it's kind of similar information, it always helps to get it just from different voices.
Sure.
So you spotted tick on you. Sure. Say, and I think we talked last time, like you're in your family, you've gotten a phone call, there's a tick. And what is your first, what do you say?
Calm down. I give the example, and that's the example from my brother-in-law who called, had a tick on his bicep, and he had to put his phone up, and I had to literally coach him through removing this tick. But I mean, just in May, my wife calls me upstairs in a panicked frenzy, and I'm like, what's wrong? What kid fell? Who's bleeding? Right? And I'm like, is this an emergency? She's like, kind of. And she goes, I've got a tick on me. I said, well, that's not an emergency. Me being me, I've been in true emergencies as a paramedic, right? Where there's life and death on the line. And when my wife has a tick, a nymphal black-legged tick had been attached for maybe 30 minutes, I go, well, that's very, very low on the level of emergency for me. Now, my wife is freaking out, as most people would, right? It is a scary thing. I mean, I've gotten ticks off my children. And most parents would be like, I imagine most parents would freak out. I am just, okay, let me tweezers, take them off, right? Because that's what I do. And that's it's this, and when we've talked about this familiarity of a risk and how you perceive what we call, and we can go into it, right? When we think about when we think about risk, humans are really interesting. The way we perceive risk is very unique. Um, and you can give basic examples of people that, and I'll give the example because I grew up in Virginia Beach, Virginia. I was an oceanfront lifeguard. I surfed my whole life. And I've never been afraid of sharks in the water. Despite seeing sharks swimming around me, we were down in the Outer Banks over the summer and someone had pulled in a 4-foot sand tiger shark. And I told my 6-year-old son, you should go up and touch it. And he was, I wish I had the picture. He was like, I want to do it. But as soon as it went up and, and I have him holding the nose up, he's terrified because he's never seen a shark before. And I'm like, well, this is normal. Like I've seen these all the time, right? I've never been bitten by a shark. They've swam next to me. But people that visit, and again, as an ocean lifeguard, they're like, are there sharks out there? And they're like, yeah. And they're like, oh my gosh, this is so scary. I'm like, well, not really. Like the chance of you getting eaten by a shark is very, 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 very low. I don't know the number, but it's probably one in a million at least, or even further down. But yet it's a real risk that people perceive. And there's a famous a risk assessment scientist, Peter Sandman. And he came up with this equation of how it's a very simple equation, kind of like my Lyme disease equation. It's a very simple equation of how we measure risk. So you have risk on one end, right? Risk equals some factors. And that is the hazard, the true likelihood of something happening, 1 in a million, 1 in 10,000, that's truth, right? That is statistics. You can calculate that. Plus outrage. Now, outrage is very different. That is more of an emotion or a feeling for humans. And that's very hard to calculate, right? Because we all have different levels of outrage. And outrage is influenced by a lot of different things. And just for example, things like something being foreign or not foreign. Going back to that shark example. I grew up around sharks in the ocean. I grew up in the ocean. Not a foreign thing to me. Not scared. But somebody maybe from the middle of America comes in and they've seen Jaws and they've seen these things. And it's more terrifying. So while the hazard, the 1 in 1 million doesn't change, right, the outrage changes up or down, and that equals our perception of risk. And I say it with the example of sharks. We can use firearms, you can use driving cars, you can use commercial airplanes, hang gliding, all these things, right? You can make those measures. Tick-borne disease, same thing, right? You can use that equation to understand hazard we can measure. 1 in 3 ticks is carrying disease. This is the likelihood you're going to encounter that tick. Can we change that? Yes, we try to change the infection rates in ticks. We try to change that risk. That's something we're trying to do, trying to change that exposure, that hazard. But we also have to understand the outrage side of the equation. What makes people afraid or not afraid? Knowledge makes people less afraid of things. So when I go out and I usually give talks, and people are like, man, I'm like itching and I'm so, these are scary things. And being scared is the first step, right? Being scared of something is the first step. And then transitioning to knowledge and becoming familiar with that concept. And the example I give is, I have a couple examples, but I'll give a personal example. When I started tick-borne disease research down in Florida with Dr. Carrie Clark, I remember I was working in the lab, and like most people, I didn't get bit by a lot of ticks. I hadn't had experience with a lot of ticks. I lived in the ocean front. We still had ticks, but it wasn't like, I remembered 1 or 2 ticks my whole life, and it always terrified me, right? When I found a tick on me, my parents always had to take it off. But Carrie and I went out we had a student walk into our office one day and she had a bullseye rash. Lucky for her, right? She had a bullseye rash. And we said, you need to go get tested. She got tested. She got her doxycycline, but she was fine. We said, where did you get that? She's like, well, we were out at the state forest in the panhandle of Florida. And we were like, Carrie and I were like, okay, let's go out camping. We're outdoors guys. So we went out camping. And we went out passively collecting for ticks. So we're just hiking, looking for ticks. And I remember coming across a male black-legged tick on my leg. And I just stopped. And I was like, Carrie, there's a tick on me. And it was crawling up my leg. And I was wearing light-colored clothes. Right. It was tucked in.
And it's crawling on your pant. It's not attached.
No, it's not.
Okay, yeah.
But and a male black-legged tick's not going to bite me. They don't bite.
Right.
So I'm calling Carrie over. He runs over and he grabs it with his hand. I'm like, oh my gosh, what did you just do? You just picked up a tick. And I was just so naive to the process. Now it's like, I'm flipped in the other edge of things because I've become so educated on these things that they don't terrify me. Excuse me. They don't surprise me, and I'm very comfortable around them. So that's it. And so my perception of risk is very different. It's driven not by outrage. It's driven by the true hazard. So that's where I think we need to target hazard, obviously, through science, but we also need to think about humans and the way we perceive or are outraged or influenced by feelings about a certain topic. And so scaring and then educating and giving people knowledge makes them more comfortable in understanding true risk.
So, okay. Yeah, no, I think that, again, it all comes back to education. And I think, too, there's, we can kind of wrap up, but one of the biggest things that we come across with ticks and we, on our social media and other things are the myths. Just,
a lot of them.
And I didn't prep you for this one, but do you have what are the top myths that you like to debunk?
I have a great example, and this is a personal example. So it had to have been when I was in my postdoc, or maybe when I started my position here. So I've been studying ticks for a decade, or maybe a little less than a decade. And I consider myself somewhat of an expert on the topic at that point in time. And my mom called me, and she told me how ticks jumped out of trees. And I said, Mom, they do not jump out of trees. And she argued me. She said, no. My mom works for a dentist, and the dentist told her ticks jumped out of trees. I said, Mom, your son's an expert on ticks, and I promise you they do not jump out of trees. I had to convince my own mother to trust me, and that, that's why do you wear a hat then? Like, well, you wear a hat so the ticks don't walk all the way up and get, under your hairline, as they climbed your whole body when they attach from on your lower appendages. So ticks don't fly. Ticks don't jump like fleas. They're creatures that don't move very much. And they don't because think about this. A tick, on average, feeds twice in their whole life. So at the larval stage, the baby, and the nymph. The adult females take a blood meal and then die, and they lay eggs and die. So think about this. Think about if you had a lawnmower, you can only fill it up twice. You'd be very thoughtful about when you mowed your lawn.
Right.
Right. So I kind of think about that. Mosquitoes bite all the time. Fleas can take multiple blood meals. Ticks are not that way. So they have to really conserve that finite amount of energy they have, or they just shrivel up and die. So ticks do not jump. They do not fly. They crawl very little. I guess the other myths, I'm trying to think of some of the other myths that I get. The ticks flying and jumping is a big one. I don't even know. That's the biggest one. Do you have something?
Yeah, that's probably the other one that we probably get most.
Yeah,
it definitely because even we're talking to some the falling of a tree. They're like, that's just how long would it take for a tick to even crawl up a tree to then come down and then
then they would dry out, right?
Having to land on the
and they would dry out. And they're not parachuting in like paratroopers, right? It's a very bad strategy if I was a tick to fall out of trees.
Yes. And then I guess the other myths that we hear most about are just how to remove.
Oh yeah. You get the I hear all the stories about these different tools or putting petroleum jelly or an salt. I don't know. I like all these types of things and realistically, and I've removed that tens of thousands of ticks from different types of animals, all different types of animals, from small little voles up to raccoons and deer and humans. And I would consider myself somewhat of an expert on removing of ticks. And it literally is these, and I probably have some here. It's those fine tooth tweezers that you just grab the base and pull out. And they're phenomenal. Now, you have to remember that I have a steady hand when I'm doing this, and somebody that's scared maybe, be a little more shaky. So it takes calming down, breathing in and out to do that. And it goes back to my example of my brother-in-law putting his bone, shaky bicep, and then the mouth parts, right? Oh, did I get the mouth parts? I always get that.
Right, because that's one thing if you don't get the mouth, because explain that. Do you need to get the mouth part out?
Yeah, so the tick has two body parts, right? They have the abdomen and the head, just like a spider does, right? Insects have 3 segments, ticks have 2 segments. And the head it kind of consists of this, I'm trying to see, I probably have a good picture on here, do I? Yes, I do. So I got a thank you card from my students. So, and they put this cool tick on there. So they have 2 body parts, right? They have kind of this body part here, the abdomen that fills with blood. This is the female black-legged tick. And then the mouth parts right here. And they have a little like it's called the basis capituli right here. So there's a little connection right here. And sometimes you can grip here and pull that connection right here apart. and you'll get these mouth parts because these mouth parts have barbed teeth, kind of like a fishing hook. They kind of stick into you. The tick also releases a cement to help stay stuck in. So people are like, well, what do I do? And it's like, well, don't start digging into it with a needle or anything like that, right? You're likely fine. Once you remove this, the tick's going to die. The mouth parts are going to be like a splinter that your body will eventually push out. People are always worried about, well, it's still going to transmit disease. And it's like, well, if it was on long enough to transmit disease, then the mouth parts being left in are not going to increase that risk anymore. So some diseases, some of the viral diseases are transmitted very quickly within 15 minutes. So having the mouth parts in is not going to change anything unless you've got them within the first 2 minutes, right? So I would say don't focus so much on that. Put some antibacterial ointment on there, cover with a Band-Aid. I like to give this tip, more myths, right? The rash, right? This idea of a bullseye rash. Well, it wasn't a bullseye rash. I'm like, well, it's actually not always a bullseye rash. A lot of times people don't recognize a rash, realize a rash. They don't see central clearing like the target sign, right? It could be just a red rash. It could be a purple rash. So I tell people, the rash itself is not bullseye. It is expanding red is what that rash's name is. Erythema migrans, an expanding red rash. Doesn't matter if it's bullseye. So when I tell people, because a lot of people will have this irritated area after a tick bite, take a Sharpie marker and just trace the outline of that red ring. And if you wake up the next morning and that red ring is bigger than your Sharpie marker, that's an expanding red rash. You need to go see a doctor.
That's a great tip.
You don't need that central clearing to be diagnosed with an erythema migrans after a tick bite.
Yeah, I think. I think the bullseye ends up. I mean, it's probably also what it's become almost a disservice because people say, "Well, I never got the bullseye, so that tick probably wasn't infected."
And some people get rashes in areas that are not where the bite was, right? Erythema chronica migrans. It's a very common feature in Europe, but you can get spotty rashes away from the bite area. So you have to remember it's this expanding red rash, not this bullseye rash. So that's a good education point to kind of change people thinking about what that sign is for likelihood of Lyme disease.
Right, because then I like that because the bullseye falls into that. So it's more like bullseye would be one of that type. Yeah, that's very good. That's a great tip. Well, thank you so much. It's really we love learning more and more about ticks. And like you say, the more we know about them and we're aware of them, we don't have to be scared of them, but protect yourself with, other repellents and do your tick checks and just be alert and know what's going on. Know your freckles.
Know your freckles.
That'd be good. Well, thank you so much, Brian, for your time.
Yes, Mary. Thanks a lot.
Thank you.